Okay, welcome to the video walkthrough of your first monthly assessment on atoms, moles and electrons. So use this to help you go through the paper, make sure you are able to answer all the questions as a result of this video. Question 1. So this question is looking at numbers of protons and electrons and neutrons in two different isotopes of magnesium. So you've got magnesium 24, magnesium 25. So the 24 here then obviously is your atomic mass for this particular isotope, or the isotopic mass for these individual isotopes. So using this number and the periodic table, you can quite quickly work out protons, neutrons and electrons. So if we know it's magnesium 24, the total number of protons and neutrons has got to equal 24. So if we find magnesium on the periodic table, you will see the magnesium has got 12 protons because the atomic number is 12. So that would be the same for both isotopes of magnesium because they are isotopes, they are the same atom. Okay, just have different numbers of neutrons. So therefore, the electrons will also both be 12 because an atom has got to have the same number of protons and electrons because it's electrically neutral. So therefore, the neutrons will be the difference between your number of protons and the atomic mass there. So 24 minus 12 means there are 12 neutrons for that one. 25 minus 12 means there are 13 neutrons for the second one. Part 2. A sample of magnesium contained 78.6% magnesium 24, 10.11% magnesium 25, and 11.29% magnesium 26. Calculate the relative atomic mass of the sample of magnesium and give your answer to 4 significant figures. These calculations aren't difficult to do, but it's only 2 marks, and if you fail to spot that particular instruction there, then you cannot get both marks. You'll only ever get the one. So watch out for any rounding instructions that are given in questions. They happen very commonly. So if I'm calculating relative atomic mass, it's always the sum of the isotopic mass multiplied by the abundances all over 100. So in this case, it's going to be 24 times by 78.6 plus 25 times by 10.11 plus 26 times by 11.29 all over 100. Pop that number into your calculator and you should get 24.3269. That's the answer that comes out on your calculator. Now again, the instruction is to round this to 4 significant figures. Okay, so the 4 significant figures will be 1, 2, 3, 4, so I'll be rounding here. So 24.3269 will become 24.33 to 4 significant figures. Okay, marking for this one then, you get 1 mark for your workings out. So it's always a good idea to show your workings. Try and avoid just writing the answer on the final answer line without any workings, because if the answer is wrong with no workings, you get nothing. But if the answer is wrong with the correct workings, and it's just been an issue with your calculator maybe, you'd still get 1 mark. So make sure you always show your workings. Part 3, define the term relative atomic mass. Definitions, easy marks. Make sure you just learn the list of definitions and keep practicing and keep reciting them to yourselves. You're not going to get very many on the exams, but the ones that do come up, it's marks you can't afford to lose. So it's a really silly one to try and drop marks on. So what is it? Relative atomic mass is the weighted mean mass of an atom. I'm going to underline that word, I'll come back to it in a second. The mean mass of an atom compared to 1/12 of carbon-12. Okay, those are the main marking points the examiners will be looking for. The first statement here, you must say mean or average, because that's what you're doing here. In essence, you're working out the average. That's what this means. So you have to say mean or average mass, and you must say of an atom. It's very common we see students say mean mass of an element or mean mass of a compound. That doesn't make any sense at all. It's the mean mass of an atom compared to 1/12 of carbon-12. So carbon-12 is the standard that these are measured against. And 1/12 of 12 is 1. That's why it's termed a relative atomic mass. It's being compared to 1. But that 1 is coming from 1/12 of carbon-12. And part C, Epsom salts can be used as bath salts to help relieve aches and pains. Epsom salts are crystals of hydrated magnesium sulfate. A sample of Epsom salts was heated to remove the water. 1.57 grams of water was removed, leaving behind 1.51 grams of anhydrous magnesium sulfate. So we've got a calculation that's been broken into 3 individual bits. So you've got a little bit of help here in guiding you what it is you're going to have to do. Okay, water crystallization calculation. So you're looking to find out the number of moles of water, looking to find out the number of moles of the anhydrous salt, and it's a comparison of the two to find out what X is going to be. And that's what you're doing here. So first of all, calculate the amount of moles of the anhydrous magnesium sulfate formed. Well, we've got the mass here of the anhydrous salt. This means the salt without the water. So number of moles is always the mass divided by molar mass. So it's going to be the mass of the anhydrous magnesium sulfate, 1.51, over the molar mass of this, which is going to be 24.3 plus 32.1 plus 64 for the four oxygens. So let's quickly do that. 24.3 plus 32.1 plus 64 for the 4 oxygens is 120.4. Okay, 2 marks for that one, so you get 1 mark for that on its own. If you calculate correctly the MR, there'd be a mark present for that. So 1.51 divided by 120.4 equals 0.0125. When you're putting your final answers down in these multi-step calculations, always look at the number of significant figures that are given to you in the question. So both masses have been given to 3 significant figures. So your answers should not be rounded to anything fewer than that. All right, that's your appropriate number. So you shouldn't really write 0.013 here. If you keep it to the same number of significant figures that's in the question, then you should be okay. Just avoid over rounding too soon. Part 2, calculate the amount of moles of water removed. It's the same thing. All right, obviously only 1 mark for this one because calculating the molar mass of water is too easy to warrant a mark on its own. So we're doing the same thing there. Moles is mass over molar mass. There's the mass of your water. 1.57 divided by 18 gives us a moles of water. It's been calculated back in. 1.57 divided by 18 equals 0.0872 recurring. So we just put 0.0872. Again, 3 significant figures, just like that one, and just like the values in the question. Sorry, my lights have just gone off. Bear with me a second. Part 3, calculate the value of X in the magnesium sulfate.XH2O. So what you've got now is your number of moles for both the anhydrous salt and the water. So it's just now figuring out your simplest ratio. So it's almost like an empirical formula style calculation. You divide both the number of moles by the smallest to give you a 1 to something ratio. So quite clearly 0.0125 is smaller than 0.0872. So X will be equal to 0.0872 divided by 0.0125. Okay, because you divide that by itself, it's obviously going to be 1. Therefore, the other division will be X. If I bring this back in, we can see 0.0872 divided by 0.0125 gives us 6.9. So we give that to its whole number, which is 7.